Welcome back. Section 1-8 Inequalities. Solve the linear inequalities, give solution in interval form, in set builder form, and graph the solution set. 3x plus 5 less equals 7. You want to solve for x. Get rid of plus 5 by subtracting 5 from both sides. Plus 5 minus 5 go away. 7 minus 5 is 2. You have 3x less equals 2. Now you want to get rid of 3. You need to divide by 3. With inequalities, you do need to worry about whether you're dividing or multiplying by a positive or negative number. In this case, 3 is positive. Division by a positive number does not change inequality. So you may divide by 3. 3's go away. X is less equals 2/3. How do you graph a solution like this? That's your number line. Somewhere here is 2/3. X less than means to the left of 2/3. So everything to the left of 2/3, and equal indicates you have to fill in 2/3. Solution set in interval notation. How do we write interval notation? You read from the left. There is no point in the left. There is a concept called negative infinity far away to the left, which is open interval, that is parentheses, and you come all the way to 2/3. 2/3, because it is included, you use a bracket. This is the interval notation of this red shaded part of the line, number line. Whereas in set builder notation, what you write is you use braces. You see the difference? That's parenthesis, that's bracket, and these are called braces. You write braces, you write x, you write in a vertical line, and then write x real number and the final result you got, x less equals 2/3. The way it is read is the set of, that's what braces mean, the set of x's such that x is a real number, x less equals 2/3. Okay, this is set builder notation, this is interval notation, this is graph, all of that of the solution. Here is another inequality. 5x minus 3 greater equals 7x plus 2. You want to combine the x's together. So we are here subtracting by 7x. Subtract by 7x. 7x minus 7x go away. 5x minus 7x is negative 2x. Negative 3, and this on the right hand side is positive 2. First, I'll get rid of that negative 3 by adding 3 to both sides. When you add 3, negative 3 addition plus 3, they go cancel each other. You are left with negative 2x on the left. 2 plus 3 is 5 on the right. Negative 2x greater equals 5. Now divide both sides by negative 2. Now you see, with an inequality, if you multiply or divide by a negative number, the inequality changes. So greater equal became less equals. Multiplication division by a negative number changes inequality. So negative 2x over negative 2 less equals 5 over negative 2. You get x less equals negative 5 over 2. So the graph is somewhere on the number line is negative 5 over 2. Equal means you have to fill in that number. Less equals means you have to go all the way to the left, all the way to the left. So what is the solution set? You read from the left. That's negative infinity and infinity, positive or negative. It's always parentheses, that is open set. Negative infinity, comma, negative 5 halves. Negative 5 halves is included, so it's a bracket. That's your solution set in interval form. Solution set in set builder form, the set of x such that x real number, x less equals negative 5 halves, negative 5 halves. So whatever final answer I get, I have to write here. Everything else stays the same. Here is another question. 5x minus 3 less equals 5x minus 2. Let me combine the two x's. So I'll subtract 5x, subtract 5x. Notice what happened. 5x minus 5x, they cancel. 5x minus 5x, they cancel. I have negative 3 less equals positive 2. Notice the x terms have cancelled out. Whatever is left is a true statement. Negative 3 is of course less than or equal to 2. When the variables cancel away and you are left with a true statement, then every real number x is a solution. So the graph of the solution set is everything. Solution set in interval notation. You are starting from negative infinity, going all the way to positive infinity. Notice infinities are always open. That is, you have to use parentheses. In set builder notation, you would say set of x such that x is a real number. Notice there is no condition on x. So x is a real number, that's it. Next question. 8x plus 3 greater equals 8x plus 5. I have x's on two sides, so I'll combine them. Subtract 8x from both sides. Notice 8x is cancel, 8x is cancel. I'm left with 3 greater equals 5. The x terms have cancelled. 3 greater equals 5. Is 3 greater than 5? No. Is 3 equal 5? No. So this is a false statement. The x terms have cancelled and we have a false statement. That means we have no solution. Whenever x terms cancelled and there is a false statement, you have no solution. You see the difference between this and the previous case. When you have a true statement, every real number is a solution. When you have a false statement, you have no solution. What about the graph of the solution set? Well, no solution, so I don't shade or color anything. Number line is left empty. Solution set in interval notation. You draw a circle with a small segment across it. That symbol denotes empty set. In set builder notation, again empty set. Okay, circle with a line across, it's called empty set. There is no solution. Here is another type of question. That's a degree 2. X squared less than 7x plus 30. Since you have higher degrees, since this is a polynomial setup, move everyone to the left hand side. How do I move positive 7x there? I subtract 7x. How do I move positive 30 over to the left? I subtract 30. Whatever I do here, I must do here, right? So 7x minus 7x, 30 minus 30, they will all get cancelled. I have 0 on the right. On the left, I have x squared minus 7x minus 30 less than 0. Now let's see whether we can factor the left. Factors of negative 30, which combine to be negative 7. Indeed, negative 10 plus 3. Negative 10 times positive 3 is negative 30. Negative 10 plus 3 is negative 7. Okay. Factors of negative 30 that combine to be negative 7. X minus 10, x plus 3 less than 0. Now we have seen such questions before in our previous sections. Identify cut points. Set each factor equals 0 and you get x equals 10, x equals negative 3. These are your cut points. How did I get negative 3? Subtract 3 from both sides. How did I get positive 10? Add 10 to both sides. This is how you solve for x. But these are just cut points. Once you take a number line and cut with these 2 points, here that's your number line, you place negative 3 and you place 10. Notice 10 comes to the right of negative 3. So you see those open circles means I have removed those numbers from the number line. So I've cut the number line here. So I get an interval negative infinity to negative 3 open because that point is no longer there. Negative 3 to 10 open. 10 to infinity open. Open, that is parentheses. When you write parentheses, it's open interval. All right. Now you have these 3 intervals, right? Open intervals. Choose a test number from each interval. From here I have chosen negative 4. From here I have chosen 0. From here I have chosen 11. Remember the 2 factors, x minus 10 and x plus 3. Sine of x minus 10, sine of x plus 3, and then the product. How do I find the sine? I plug in my test numbers. Negative 4 minus 10 is a negative number. 0 minus 10, negative number. 11 minus 10, that's positive number, positive 1, for example. Sine of x plus 3, negative 4 plus 3, that's a negative number. 0 plus 3, positive. 11 plus 3, positive. This is multiplication. Negative times negative, positive. Negative times positive, negative. Positive times positive is positive. So this is the sine of x minus 10, x plus 3. What is the question? Let's check again. That is indeed the question. Remember, that was our original question. We moved everything to one end, factored. That is the question. So the question is x minus 10, x plus 3 less than 0. Less than 0 means it should be negative. Here, notice the middle one alone is negative. So the interval is negative 3 to 10. Because it is less than, I don't use bracket. Bracket is to be used when I have equal. Solution is open interval negative 3 to 10. That is in interval form. In set builder notation, set of x such that x real number, what is this? X between negative 3 and 10. Well, of course, you're going to live between these two because that's what is negative. Okay. So x is between negative 3 and 10. That red shaded region is where x allowed to live. So that's your set builder notation. That is the graph. Notice I don't fill in the endpoints. My red shading does not fill in the endpoints. When I say fill in, notice that's filling in. That's filling in. So in this case, I don't fill in because I don't have an equality. So this is the solution for our given question. We'll continue with the next video.